All right, we are continuing on with this chapter 1. It should say A right here. Chapter 1A. Remember, it's the chapter before we actually jump into the book. So today is all about absolute value, opposites, and reciprocals. It should be in your notes packet, so get those out. If you ever lose your notes packet, I have a couple extra, or you can just write what we're doing on a sheet of paper. Keep it like that. But try real hard not to lose your notes packets, okay? A little noisy. All right, you can see our schedule for the week is over on the board. We will have a quiz on Wednesday. Yeah. Most of my classes actually had a quiz last week, so you guys are my last class to have a quiz. That will be on Wednesday. We're going to do some sort of a review on Friday. I'm not quite sure what it's going to look like, but we have notes on Monday, review tomorrow, quiz, and then another set of notes on Thursday. So first we'll look at opposites. Here's the definition. Two numbers which are the same distance from the origin. That's sort of the fancy way to say it. The easy way to say it is if it's a positive number, make it a negative. It's a negative number, make it a positive. Okay? So the opposite of 5 is negative 5. The opposite of negative 5 is 5. You just change the sign. All right, so another way to think of opposites is you can just add another negative sign. Okay, so if I said negative 6, what would you say? Positive 6. So this is like saying the opposite of negative 6. All right, so when you add an additional negative in the front, it's like saying the opposite of whatever's in parentheses. Okay? So the opposite of negative 6 is 6. Any questions? What is the opposite of 8? Negative 8. What is the opposite of negative 1,500? 1,500. Good. Opposites are not tricky. I mean, this should feel like, oh yeah, I get it. Does anyone not feel like, oh yeah, I get it? Okay. Got jokes on a Monday. All right, absolute value. Absolute value's definition is the distance away from 0 on a number line. Distance is never negative. So the absolute value of something cannot be negative. Once you take the absolute value, it's positive. Like we just saw with the number line activity. What are your questions? All right. We write absolute value using those bars right there. So whatever is inside the bars becomes a positive. So if I want the negative absolute value of negative 16, it's sort of like order of operations, a grouping symbol. You got to do the absolute value part first. So what is the absolute value of negative 16? 16, but you still have this guy out front. So the overall answer here is negative 16. So what's inside the bars becomes a positive. And you got to do that first. And the reason is it's a distance, and distance is never negative. What?
I thought your name was Miss Bundy.
It is.
No, I said, no, she said this Miss Mayberry teaches this. I said, yeah, Miss Mayberry taught us.
Okay. Any questions about what we're doing today in this class? Okay. All right. Whoa.
Oh.
That escalated quickly. All right. Order of operations, I am going to start inside the grouping symbols in the innermost grouping symbol. So I'm going to start right here. Is there anything I can do with just the negative 10 part?
No, ma'am.
No, so I'm going to take it out to the next grouping symbol. What's a negative 10? Positive 10. So I still have this guy, still have this, still have this. Open a bracket. This negative sign is still there. These two have become a positive, leaving me with a 10. Okay? So 3 negative signs. You can get rid of 2 of them. Now we just have 1 negative. All right? Questions?
So, what, real world math problem uses them?
The order of operations.
With all the brackets.
I mean, lots.
I don't get the point.
We're just practicing simplifying numbers so that we can get deeper into harder math. Yeah. So this will lend itself to a lot of real life situations. This actual problem, will you need to be in the middle of Walmart someday solving it? Probably not. But this will open the door up to a lot more applicable stuff that will come up. Okay, I'm going to do the absolute value with the grouping symbols. So what is the absolute value of negative 40? 40. That is going to turn into just a multiplication symbol. If you want to use a dot, go for it. If you want to make it a bracket instead of absolute value, go for it. But once we take the absolute value of a negative number, it becomes positive. I can write this next part as well. What is 50 times 40?
200.
200. Plus, what is 6 times negative 10?
Negative 60.
All right, so I'm actually going to take that back and make it a minus 60. Is everyone down with that?
Yeah.
You could put plus negative 60 if you want. Same thing. Okay, what is 200 minus 60?
140.
Raise your hand if you have any questions. So I am going to. Where do you guys think we should start? Let's.
4 minus 2.
Yeah, I think we should start back here, simplify it, and then just do all the absolute values. So I'm going to keep the absolute value of negative 8, minus keep the absolute value of 10, minus 6 times the absolute value. What is 4 minus 10? Negative 6. What is the absolute value of negative 8? 8. Minus, what is the absolute value of 10? 10. Minus 6 times, what is the absolute value of negative 6? 6. And again, back there, I couldn't just drop a symbol completely, and it would look like 66. So either put a dot for multiplication or put it in parentheses. So you get what I'm saying back there? Does that make sense? Okay. A number right next to an absolute value symbol means multiplication. So you can't lose that piece back there. All right, keep the 8. Keep the minus 10. What is? Perfect. All right, and now we're on just addition and subtraction from left to right. What is 10? Whoopsies. What is 8 minus 10? Negative 2 minus 36. Negative 38. What are your questions? The definition of reciprocals. It kind of makes it more confusing. It makes it more confusing than it needs to be. Reciprocals are two numbers whose product is 1. You basically flip the numerator and the denominator of a fraction. So if I want the reciprocal of 3, first you make it a fraction, then you flip it. The reciprocal would be 1 over 3. If I have 2/3 and I want the reciprocal, I flip it and make it 3 over 2. So a reciprocal is just a fancy way of saying flip the fraction. If it's not a fraction, make it a fraction. Number 7, what is the reciprocal of 4? 1/4. So think of it as 4 over 1. When you take the reciprocal, you just flip it 1 over 4. So you have to make it a fraction first, then you flip it. For real. Okay. Now, you can't flip a mixed number. So what do you think I need to do first?
Make it a proper fraction.
Yeah, so we need to do 9 times 5, which is plus 2, which is, so 47 over 9. Flip it, 9 over 47. Any questions? All right, what are your ideas on this one? Turn it into a fraction. Does anyone know how to turn 3.2 into a fraction? Yeah, so you gotta think back to what you know about place value. This is the ones place, right? That's why we put those numbers over 1. That's not gonna work here because we have another place. This is called the tenths place, which means anything ending in that spot can be made into a tenth, which means putting it over 10. All right? So you start by just making it into a fraction. Now, it gets even trickier because we can reduce this fraction. How would I reduce that fraction? By 2. It would be negative 16 over 5, and now we flip it. So what is the reciprocal?
Negative 5/16.
Negative 5/16. Good. That was a lot. Let me know if I lost you. When you divide fractions, what do you do?
Change, flip.
Good. So we're going to keep the first one. Change the second one. I lied. You keep the first one, you change the sign into what? Multiplication, and then you flip the second fraction. All right, so the first one's fine. Instead of a division symbol, we make it a multiplication symbol, and then we take the reciprocal of the last. Keep, change, flip. Right. Okay, so here is our first example. So we're going to keep, we're going to change, and then we're going to flip. Keep, change, flip. Now, before I actually do the multiplying, remember you can simplify across the multiplication symbol. Any numerator simplifies with any denominator. So what's going to happen on this one? 25 and 35 can become 5 and 7.
8 and 20 gonna be 10 and 4.
Two and 5.
10 and 4 works. If you divide them both by 2, you'd get a 10 and a 4. But 2 goes into both of those numbers as well. So you could do it again, or you could just go straight to dividing them both by 4, because 4 is the greatest number, the greatest common factor. All right, now multiply across the top. What's 5 times 5?
25.
What is 2 times 7?
14.
14.
No, you change it.
Make that into an improper.
Okay, yeah. First, remember, keep, change, flip. I can't flip a mixed number. So the first thing I want to do is we can't even start keep, change, flip until we can do all 3 steps. Okay, so what is 5 times 5? 25 plus 2, 27. Now, I would do it exactly like I'm doing it. I heard you guys, don't keep, change, and then make it, you're gonna miss a step, or you're gonna flip it too many times. So just write it out first, still as a division problem, make everything improper that needs to be improper, then go for it, okay? So keep, change, flip. Oh. I don't know how to simplify any of this.
Aren't you a math?
No, I'm just saying, like, 5 does not go into 121, right? Multiples of 27 are 3 and 9, and neither of those go into 55. 55 also doesn't go into 50, or 27 doesn't go into 55 on its own either. So yeah, we're just going to need to multiply across the top. So like old school. How do I do that?
5 times 5.
5 times 5 is 25. So we write the 5, we carry the 2. 5 times 5 again is 25 plus the 2. And remember, we don't have calculators yet, so this is really the only option at the moment. No, you're not supposed to use calculators yet. I am aware they exist. I am aware that you probably have one. We're just not supposed to be using them.
Yeah.
All right, what's the issue? Okay, what is 7 times 1? What is 7 times 2? 14. So I write the 4, I carry the 1. What's 7 times 1? Plus 1, 8. Okay, this is where it gets a little tricky. The 2 is in the tens place, so it's kind of like multiplying by 20, right? So you got to hold that place with the 0. What's 2 times 1? 2 times 2. 2 times 1. Now we can add them. Okay, before I would box it in, I would check the divisibility rules. Do you guys know if it's an even number, it's divisible by 2? Do you guys remember the 3's trick?
Go.
If you add the digits and that number is divisible by 3, then the number is divisible by 3. When you add 2, 7, and 5, you get 14. That is not divisible by 3, so the number is not divisible by 3. If it's not divisible by 3, it's not divisible by 9. For the divisibility rule for 4, you just check the last 2 digits and see if they're divisible by 4. I think we're done on this one. I don't think they're going to simplify. Any questions? Where do you want to start?
Make that 7 and
And a 7 is a fraction.
Very good.
So what should you do?
Good. So the 14 over 9 is fine. The 27 over 8 is fine. Now, remember, multiplying and dividing happens from left to right. So technically here, I'm going to keep, change, flip.
And then we had to change it to flip again, right?
I did not do anything here. I did not do anything here. I kept this the same. I changed this. Then I flipped this. Is everyone still with me?
Yeah.
Now, I'm writing it out in 2 steps just to show you that technically, after flipping it once, I am keeping the 1/7. I am changing the sign, and then I'm flipping. If you feel confident keeping, changing, flipping both at the same time, that's fine. I'm worried you're going to double flip this guy. So you flip it, then in the next step, it becomes the keep number. You know what I'm saying? Yeah. All right. Now, any numerator can simplify with any denominator. For example, even though the 14's way over there and the 7's way over here, one's in the top, one's in the bottom, you can take care of them.
And 3 and 9.
The 3 and the 9. There's a couple more. So we can do, what did you say?
3 and 27.
Yeah, you can use the 3 now with the 27 and make it a 1 and a 9. What other one can we use? The 8 and 2 can do 1 and 4.
I'm so confused.
Okay.
Which part did you get confused on?
I'm losing my
What y'all doing now? Y'all simplifying.
We are simplifying any number in the numerator with any number in the denominator if they share a common factor. So for example, we did the 3 from back here and the 9 right here. 3 goes into both of them, so I made this one a 3, I made this one a 1. Then I noticed that 3 and 27 are also both divisible by 3, so I kept it going. So it's basically just a lot of dividing numbers out of the numerator and the denominator to simplify the numbers we're working with.
So it's gonna be not 40.
So up top I have 1 times 9 times 1 times 1. And in the denominator I have 1 times 4 times 1 times 1. There is not a common factor of 9 and 4, and you don't need to make it a mixed number, so we're good. This one is going to be kind of tricky. We're going to have a fraction within a fraction. So we start with 5 over 2 over 5 minus 6 over 3 over 2. So it's a fraction within a fraction. The easier way, and I rarely encourage you to use the old school division symbol, but this is when it is helpful, okay? The easiest way to think about this is to change these guys into the old school symbol, okay? I'm also going to make these both over 1, okay? So this is going to be 5 over 1, old school division symbol, 2/5, minus 6 over 1, old school division symbol, 3 over 2. I am going to pause for you to process. Okay, so I think the next thing I should try...
What's that 3 cut off? Is that a 1? Period.
Yeah. So 5 times 5 is,
25.
and 1 times 2 is 2. So the first fraction is 25 halves. Still have the minus sign. Now I made the 3 a 1 when I simplified it with the 6.
Yeah.
So I have 2 times 2 on the top. That's 4 over 1. Now, do not forget how to subtract fractions. I just know someone they're getting in they're in the wrong house. They're still thinking you're multiplying, and they will cross these 2 out. You cannot do that over a minus sign. What we need are common denominators, which is 2. So I'm going to multiply top and bottom by 2. Common denominators. So 25 over 2 minus 8 over 2, which is what? 17 over 2 is my final answer. That's a lot. Take a minute, process. So I am going to start by rewriting this. I am going to take the x's out, put a negative 2 in, take the y out, put a 1 in. So I am just rewriting this. X's turn into negative 2's, y's turn into 1's. All right, grouping symbols, which absolute value is considered one of, that's where we need to start. So I'm going to do the order of operations in this guy, then I'm going to take the absolute value of that number. So I have a 4 out front. What is 2 times negative 2? Negative 4. What is negative 4 minus 1? So this is 4 times the absolute value of negative 5 minus negative 2/5. What is the absolute value of negative 5? 5. So this is 4 times 5 minus negative 2/5. And you get 20. And I just heard someone say it. Put it over 1. I am going to clean up this sign as well because it's sort of driving me nuts to write a minus negative each time. What could I do?
Plus.
Write a plus, yeah. Plus a positive. All right. Now I can simplify the 4 and the 5, right? I mean the 20 and the 5. Can I do that? Make it a 4 and a 1? Why not?
Because it's not multiplying.
It's not multiplication. I see it every year. It makes my skin crawl. Don't do that, okay? There's a plus sign in the middle. You're in the wrong house. How do I simplify when I have a plus and I have some fractions? Common denominators is correct. So the common denominator here is what? 5. So I'm multiply this guy by 5 over 5.
It'd be 100.
So 100 over 5 plus 2 over 5. 102 over 5. All right, I think a few of you might need extra time with this. So I'm going to put our summary right into this slide. Today we learned a lot.
Come on. You gotta do this.
What's the first thing we talked about?
Absolute.
We learned first,
We talked about opposites, period.
we did opposites. We did absolute value.
I just put a
We did reciprocals. You can put recip. We also did dividing fractions.
Oh my god, that was so fun. I remember we did that.
I know. How could we forget that? And then sometimes I just like to put etc. because I'm sure I forgot something. It just sort of covers it for us. All right, here comes your homework.